In the last video, I introduced the concept of completing the square with a beautiful derivation of the identity. If you haven't seen that, I'd suggest you go watch that before you watch this video. Okay, so in this video, we're going to further understand or develop our understanding of how exactly do we bring an equation or sometimes an expression in in completed square form. Okay, now I should mention that before I start, that completed square form basically looks like this: ax minus h, the whole thing squared, plus k. And I'll later elaborate on what h and k basically represent and what a represents basically. Okay, now so I've written a couple of identities here. You must have noticed that I've left them not entirely blank, but I've left the last part. So x plus 5, the whole thing square, is a no-brainer. It's going to be x squared plus 10x plus, now what we're going to add towards the very end is going to be the square of 5, which is 25. Okay, and then you have x squared plus 12x plus x plus 6, the whole thing squared, which is going to be x squared plus 12x, and then what we're going to add towards the very end is going to be 6 squared, okay, which is 36. In fact, I'm going to rewrite 25 and I'm going to write it as 5 squared instead. And again, same goes for the last part, x minus 7, the whole thing square. This time it's going to be x squared minus 14x plus 7 squared. Now here's something that I want you guys to observe. Now if you look at the coefficient of x, and if you look at the term that we add at the very end, you will identify a certain pattern. Now again, I should mention that in all the questions that I'm going to do, we'll make sure that the coefficient of x square is 1. Okay, and whatever I'm going to teach you in this video applies to when the coefficient of x square is 1. When it's not 1, then we do something else, which is something I'll teach you guys later. Now in the second example, we have 12x as our middle term, or the 12 as our coefficient of x, and what we're adding is 6 square. So notice something is that the term that we add, or the term that we add after squaring it, is always half of the coefficient of x, and then we put a square on it. Okay, so 7 here is basically half of 14, and then due to the identity a plus b, the whole thing square, we put a square on it. Okay, and the same thing applies to this 5 here. 5 is half of 10, and then we square it and then we add it. Okay, so now here's how this works. So what this pattern basically does is it basically helps us understand what we need to do if we want to convert an expression. Okay, so right now I'm going to be talking about expression in a completed square form. Now suppose you have x squared plus, let's say, 4x plus 7, and the question asks you to convert this expression. Now remember, this is an expression because it has no equals to sign, into completed square form. Now the way to do that would be, now this is the way that I like to teach my students to do it. So what you do is you do x squared plus 4x, you put a plus sign, you leave some space, and then you write whatever is left from the original expression, which is plus 7. Now the real question is, what exactly do we need to add over here? Okay, now in order to find that out, what we do is we look at the coefficient of x, which is 4, we divide it by 2, which is 2, and then we square it. So that means I'm going to add 2 square in this expression. Okay, now since I've added something in this expression, I need to offset its effect. So I'll do that by subtracting the same thing. If this were an equation, what I'd do is I'd add 2 square on the left hand side and add 2 square on the right hand side. But since it's an expression, so I'm going to add 2 square. In order to offset its effect, I'm going to subtract 2 square. Now what this becomes is, this compresses into x plus 2, the whole thing square. Okay, you can expand this and see if you get x squared plus 4x plus 2 square or not. You will, of course. And then what do you have at the very end? You have 7 minus 4, which is plus 3. Okay, so 7 minus 4 is 3, and that means if you were to expand and simplify this expression, you would notice that you would get the original expression. Now this was one example. Okay, I'd like to do at least 2 examples. Now in this example, let's say you have x squared. Now I'm going to put a minus, and I'm going to have an odd number, okay, just to spice things up. And let's say you have plus 1. Okay, now again, same rules. You have to convert this expression into completed square form. So here's what you do. You do x squared minus 3x, put a plus sign, leave some space, and you write and you carry down the leftovers. Okay, so what is it that we need to add? Well, the coefficient of x is 3. It's actually minus 3, but we're just going to ignore the sign for now. It's 3. Now I'm going to divide 3 by 2, so that means it's 1.5, or you can keep it in fraction form if you want, but in fact, I'm going to keep it in fraction form. So yeah, let me just enlargen the circle. So yeah, 3 upon 2, the whole thing square, and if I want to offset its effect, I'm going to subtract the exact same thing. So this part of the expression compresses into x minus. Now notice that I've put a minus here because the coefficient of x was negative. Okay, so that means when I compress this into the identity, it's going to be a minus b the whole thing square. So x minus 3 upon 2 the whole thing square. Now let's see what this turns into so that I can decide what sign is it going to be. Is it going to be plus or minus? So it's 1 minus 3 squared is 9, 2 squared is 4, so it's definitely going to be minus. So minus 5 upon 4. So there you go, you have x minus 3 upon 2 the whole thing square minus 5 upon 4. Now this was with expressions. Now I'm going to do a couple of examples which will involve equations. However, what I would suggest is you guys to try this on some other expressions, okay? And how exactly are you going to check your answer? Here's how you're going to check your answer. You are going to expand the compressed form or the completed square form and see whether it matches with the original expression or not. Okay, you can come up with an expression of your own. Suppose you have x squared plus 5x plus 9. Okay, try and convert this into completed square form, see whether it matches or not, and if it does, very good. If it doesn't, try again, or you can reach out to me on Instagram if you want some help. So yeah, okay, now here's part 3. Now in this, I'm going to be using an equation. In fact, I am going to say, let's suppose you have x squared plus 6x plus 5 equals to 0. Now we all know very well that you can solve this with the help of middle term breaking. In fact, we can do this in your calculator, and you will get x equals to 1, x equals to minus 1, and x equals to minus 5. Okay, we all can do that. No need to teach you guys that. However, what I would like you guys to do in this is learn how to solve this equation with the help of completed square form. Okay, so here's how this works. Now in equation, things are slightly different. So what I'm going to do is x squared plus 6x. Now take 5 on the opposite side of the equals to sign. So what do you have? You have minus 5. Okay. Now we need to decide what is it that goes over here. What is it that I need to add over here? So for that, I'm going to look at the coefficient of x, which is 6. Half of it is 3. So that means I'm going to square 3. Now I need to offset its effect. So remember, this is an equation. So whatever it is I'm doing on the left hand side, I'm going to do the exact same thing on the right hand side also. So I'm going to do plus 3 square on the right hand side. If this were an expression, so I'd add something, and in order to offset its effect, I'd subtract the exact same thing. But since it's an equation, whatever I add on the left hand side needs to be added on the right hand side also. So this compresses into x plus 3 the whole thing square. On the right hand side, however, I have minus 5 plus 3 square, which is positive 4. Now you can solve this with the help of taking the square root on both sides. When you do that, you get plus minus 2. Okay, I should write it over here what I've done. X plus 3 the whole thing square root, and then square root of 4. Okay, and square root of 4 is going to be plus or minus 2, and then of course you can solve it, and you will end up with plus minus 2 minus 3. Oops, sorry, plus minus 2 minus 3. So positive 2 minus 3 is going to be minus 1, or minus 2 minus 3 is going to be minus 5. Okay, so I'm going to do one more example for you guys, and this time, let's see. Suppose I have x squared plus, in fact, let's make it minus. Suppose you have 7x plus 6. Yeah, okay, equals to 0. Now here's what I'm going to do. First things first is that x squared minus 7x equals to minus 6. Now what is it that I need to add on the left hand side? I need to add 7 upon 2 the whole thing square. That means I need to add 7 upon 2 the whole thing square on the right hand side also. So this compresses into x minus 7 upon 2 the whole thing square, and the right hand side turns out to be, let's see, minus 6 plus 7 squared is 49, or you can write it as 7 upon 2 whole square, or you can just square it and then add it directly. So I get positive 25 over 4. Okay, now you need to take the square root on both sides, and what happens is you get x minus 7 over 2 equals to 5 upon 4, positive and negative. Okay, let me just fix this quickly. Yeah, apologies for the bad handwriting. Okay, so what do you get? You get x is equals to plus minus 5 upon 4 plus 7 upon 2, and you guys can work this out since I know what the answer is going to be, so I'll just write it directly. One is going to be 6, or the other is going to be positive 1. Yeah, So that's all for this is what I wanted to teach you guys in this video. This is a concept that has been due on me for a very long time, and hopefully it's not too late. So yeah, that's all for this video. I'll see you guys in the next one. There is something regarding completing square that is still left, which is I still need to tell you what ax minus h the whole thing square plus k basically means, what h and k represent. But for now, this is enough. Again, I will encourage you guys to practice a couple of questions on your own. Get them checked by either check them yourself by expanding and seeing whether it's matching with the original expression or not. If you can't do that, you can always reach out to me on Instagram. So yeah, that's all for this video. See you guys in the next one. Until then, take care. Bye bye.